Hey Chemistry, Miss Kane here. So I just want to spend some time talking to you guys about the photoelectric effect. So we're just gonna quick review. So our photoelectric effect tells us that there's a minimum light energy needed to eject our electrons. Okay, remember that photo is our prefix for light. Okay, and the electric piece is coming from those electrons. So we're going to come back to our energy equation. So energy is equal to Planck's constant. So it's always going to be this number, 6.6 times 10 to the negative 34. And we are multiplying that number by our frequency. So if I'm looking at my model right here, we've got this metal and we are shooting, a low frequency light at it. So this is a photon. But remember that light acts as both a particle and as a wave. So that's why we've got the little wave in there to remind you. Okay, so if we're trying to find our energy, we would take Planck's constant and we would multiply it by our frequency, of this photon. Okay, if we have a low light frequency and we shoot it at our metal, none of our electrons are going to come off, because we haven't hit that minimum light energy needed. Okay, but if I come over here and I hit it with a higher energy, so blue light has a higher energy than red. Again, we can use our Planck's constant times our frequency to find out how much energy we have here. If we hit that metal, it's going to give off electrons. We've surpassed that minimum light energy needed. Okay, so here's just another way of looking at it. Okay, if we hit it with low energy light, nothing happens. This is the energy that we need, If we hit it with something that's higher energy than the energy needed, we're going to release those electrons, They're going to be shot off. So here's just one more example, but this time we've got some numbers. So if you notice, we keep talking about this energy needed. This is also called our work function, So this number is telling us how much do we need to be able to shoot off those electrons. So if I'm shooting it with a low frequency light, you see that my work function is less than what I need for this metal to shoot off those electrons. So nothing would happen if I hit it with this light. But if we're looking at our high frequency, our high energy light, you notice that this number is bigger than our work function for the metal. So it will eject electrons. And we can figure out the energy of those electrons just by doing a simple subtraction. So we take our work function for the high energy light and we subtract the work function of the metal. And that will tell us how much energy those electrons coming off have. Okay, guys. So I know that was just a real quick overview. We'll still do some more examples. You'll get some practice with it. If you need help, come see me in office hours, shoot me an email, and we'll set up an appointment. Don't get stuck and not do anything. I need you guys to keep up with your work because we're hitting the end of the quarter. All right? So let me know how I can help you. I hope you have a wonderful rest of your day. Hopefully I'll be able to see some of you guys' faces soon. So I'll talk to you guys later. Okay, bye.